Hello, everybody, and welcome to today's installment of the Modern Analytics Academy. My name is Alex Karasak, and in this session, I'll be taking you through ways to model and serve data inside of a modern analytics solution in Azure. The agenda for today's session will include a review of the Modern Analytics Academy framework, the team behind it, an overview of a modern analytics architecture in Azure, and then finally a deep dive into ways to model and serve data in Azure. Specific topics covered will include data lake structures for analytical use cases, how Synapse fits in as a solution, and a demo of these concepts. The Modern Analytics Academy was built to show breadth and depth of capabilities in Azure that can be used to implement a modern analytics solution in the cloud. This is the team behind the program, and we're all cloud solution architects on Microsoft's Global Partner Solutions team. Okay, now let's take a quick look at the detailed sessions available as part of the Modern Analytics Academy. In data acquisition and storage, we looked at the nuances of how source systems provide data and the various mechanisms for getting that data into Azure for long-term retention and analysis. In data modeling, we'll be looking at how to structure and store your data for the purposes of serving that data to applications like reporting and analytical tools downstream. In data pipelines, we'll be looking at how to move your data through a data engineering process and prepare the data for serving. In data security and governance, we'll examine how to deal with topics like controlling access to your data, understanding the lineage of your data, and addressing policy and compliance on your data. Finally, in data visualization, we'll examine how visualization tools like Power BI can be used to enable users to get timely business value out of your data. And obviously, as I mentioned, today we'll be primarily focusing on the modeling track, which will include topics around how to structure a data lake, Synapse Spark pools, Synapse SQL pools, and Synapse Serverless pools. All right, next, for those of you who may have missed our overview session, I wanted to take a minute to review this diagram, which includes all the different components of an end-to-end modern analytics solution. First, if we consider ingestion, we need to be able to connect the data no matter where it's coming from and how fast it's being loaded. So what that means is we need to be able to ingest data from everything from line of business applications to cloud services, social networks, sensor and IoT data, as well as being able to support everything from event stream processing to batch-oriented operations that load data on some type of scheduled basis. Next, if we consider storage, we'll need to be able to support highly scalable and cost-efficient storage, which will be critical to these solutions that'll have theoretically limitless amounts of data being required to support these types of solutions that we're talking about building. And for obvious reasons, when you're talking about that scale, choosing the right method for storage is always going to be critical. Next, if we look at the Explore bucket here, where we're talking about querying all the data, what that means is that the data processing engines that we're using will need to be able to support ad hoc querying across all the different storage mechanisms that we use to land and to acquire and store this data. When we consider the prep and train category, new analytics and data processing engines, such as Spark, are going to be leveraged to prepare data and train models over all those large volumes of data that we're talking about. So we'll need to be able to transform and enrich the data. Then when we look at model and serve, if you think about it, without giving users access to this data that we're pushing through this pipeline, so that they are able to do ad hoc data analysis and build their analytical solutions, then obviously they're not going to get much value out of it. So we have to be able to surface the data in a usable way through the modern tools that are available to us. And then finally, across the bottom of the diagram here, you'll see we call out the need for metadata management and governance, because with all this data, obviously data security and regulatory concerns haven't gone away. So all this data has to be discoverable, compliant, and trusted. All right, and as we've been talking about today, we'll be focusing mostly on modeling and serving the data through our data warehouse for this platform. All right, so as I mentioned before, data is obviously fundamental to these types of modern analytics solutions. And when it comes to data at this scale, there's generally two ways to store, model, and serve the data to your consumers. So on the left here, you'll see data lakes are generally ideal for experimentation, exploratory analysis, or ad hoc queries over semi-structured or unstructured data at any scale. For more traditional type of analytical workloads like reporting scenarios or a more traditional data warehouse, you'll see on the right-hand side here, a classical data warehouse is often more suitable for serving data via a relational data model with proven security, dependable performance over aggregated operational data sets. So that's going to be more of the predictable data that you would traditionally be ingesting from a transactional system with a known data structure that you can use for aggregating and summarizing data. Whereas the data lake is going to be much more of an area where you can collect basically any type of data. But as evidenced on the diagram here, in the past, that because these two are so different, it's generally an or. So when you're thinking about how to land data or where to land data, a lot of times it's a balancing act to figure out whether that data needs to be stored as an object in a data lake or whether it needs to be modeled and loaded into a data warehouse. And that's where Synapse Analytics comes in. So by being able to support both of those scenarios, Synapse Analytics becomes the natural hub for all of your modern analytics solutions because it can support all those data warehousing use cases and all those big data analytics use cases all in one service. I like to call it a one-stop shop where you can get access to a single pane of glass that allows you to basically access all of your data across your entire data estate and perform any type of analytics necessary over it. All right, so now that I've introduced Synapse Analytics, let's talk about what that is. So I don't like to read definitions off of slides, but I think this one is worth going through because it's as I mentioned, it's going to become kind of the core of everything we're going to do from here forward in this session. So Synapse Analytics is a limitless analytics service with unmatched time to insight that delivers insights from all your data across data warehouses and big data, as I mentioned, with blazing speed. So simply put, Synapse is Azure SQL Data Warehouse evolved. And that's because, as we're going to talk about, it still has the core data warehouse service underneath of it at its core. But now you'll see that it's going to have a lot of enhanced capabilities and advanced capabilities around it that are all accessible via the same service. All right, so here's a look, a little bit of a different look at Synapse Analytics. I mentioned it's a one-stop shop for everything. So this slide represents all of the things that can be accessed through that single pane of glass. So Synapse is designed for analytics at any scale. If we start at the top here, you'll see that from an interface perspective, we do have access to the new Synapse Studio, which is a web-based portal for object exploration, data engineering, development, orchestration, all through that single pane of glass that I mentioned. In Synapse, we also offer enhanced developer experiences for code-free and code-first implementations. We support multiple languages suited for different analytical workloads. So whether that be SQL, whether that be Spark, .NET, we can support all those through the different engines. There are integrated analytical runtimes, as you'll see here in the middle of the slide, that are available in a provisioned or serverless on-demand SKUs. So what that means is you'll see here inside of Synapse, we have access to SQL engines as well as Apache Spark engines. And on the SQL side, we do have the ability to, as I mentioned earlier, deploy that dedicated SQL data warehouse or that dedicated SQL server that allows you to provision dedicated resources and scale those resources as appropriate for your workloads to be able to materialize and support your relational kind of data warehouse at scale. It also supports a serverless version, which we're going to spend a lot of time talking about today, which does not need to be provisioned. It's deployed as part of your workspace, and it provides a serverless compute that will support all of the same T-SQL conventions that you're used to, just in a serverless manner. And then for Spark, it's the same thing where you can deploy a Spark cluster, but you're only paying for it when you're using it. So that's something that you allocate and you can execute your code on directly inside of Synapse. All right, so now that we've done a quick introduction to the Synapse workspace, I wanted to take a minute and go through some key terms that we're going to be using in today's session. And I think it's going to be critical to understand some of these as we think about different ways that you can start to store your data in a way that that makes it available to these type of analytical query patterns, and also allows you to model that data and serve it up to your end users across the different runtimes that we just talked about. So the first is a data lake. So I'm sure many people have heard this term thrown around. This is obviously data lake storage, as we said, is going to be one key component to this whole architecture. This is the definition that I like. So data lake is a storage repo that holds a large amount of data in its native raw format. Data lake stores are optimized for scaling to terabytes and petabytes of data. The data typically comes from multiple sources and may be structured, semi-structured, or unstructured. And the idea is for a data lake is to be able to store everything in its original untransformed state, as well as all of the different transformed states through the different zones that we're going to be talking about today at the different points of serving that data. Next, we're going to talk about ADLS Gen 2, which is the Azure implementation of blob storage that's optimized for data lake storage for these type of analytical workloads inside of Azure. As I said, it's deployed on top of the blob storage service with a couple of enhanced capabilities for analytical use cases, specifically around the enablement of hierarchical namespaces. What that means is that inside of this ADLS Gen 2 storage, you have the ability to manage the storage at a folder level, which is key for performance and security concerns around building out your data lake. And what that means is you're able to manage access of the data from a permission standpoint and from a data access standpoint at a folder level, which provides a huge benefit around security and performance of your data lake workloads, because you can do things like eliminate partitions when you're querying data, which means you don't need to scan an entire container when you're querying data that's stored within one of these ADLS Gen 2 buckets. The next term is data warehouse. So a data warehouse is a centralized repository of integrated data from one or more disparate sources. Data warehouses store current and historical data and are used for reporting and analysis of the data. I think we're probably all familiar with data warehouses. They've been around a long time, but the key here is that typically in the data warehouse, the way that we're going to be using that term today is that we're talking about more of a relational data store. So that would be something like a star schema that people would be used to, which is, again, the relational data model that can be used to surface data in different analytical tools. And then finally, a logical data warehouse, which is a relational layer built on top of Azure data sources such as ADLS Gen 2, Azure Cosmos DB analytical storage, which we covered in our last session through the Synapse link to Cosmos DB capability, or Azure Blob Storage. So we're going to talk about this more in the coming slides, but essentially what a logical data warehouse is a virtual data model that can be built using the SQL Serverless Pools in Synapse Analytics to essentially replicate the same function of a data warehouse without having to actually leverage a provision relational engine, obviously making it more cost-effective and easier to administer. And we'll talk about the pros and cons of each one of these capabilities in a little bit. All right, so speaking of that data lake and the ADLS Gen 2 implementation of that data lake, I think this is a good diagram that kind of shows the different zones that we'd recommend using when you're deploying a data lake. When I say zone, what that means is an area within your lake that would encapsulate a specific set of data. And typically that data would be categorized by the format and the use case and the audience for that data. So raw data is typically data stored as is when it's being ingested from the source systems. So this is typically ingested via automated streaming or batch-oriented pipelines, and it's consumed by some kind of analytics engine, such as Spark or managed integration pipelines in Data Factory or Synapse that would be performing cleansing or enrichment operations to generate the enriched or curated data that we're going to talk about next. So common formats for data stored in the raw data zone might include CSV or JSON, which would be optimized for efficient write operations and usually easy to generate off of the transactional sources of the data. The next zone here would be the enriched data. So this layer is the version where the raw data is either coming in as is or in some kind of an aggregated form, and we start to enhance the data with some kind of a defined schema, or we're transforming it, whether it's to clean up and provide consistent formats for things, or whether we are enriching it with some type of ML operations. And data in this zone might be stored in a format such as Parquet, which would be compressed and include the schema of that data, and it makes it much more suitable for read-heavy and analytical workloads. So users accessing data in this zone might include data scientists or data engineers who are writing jobs to transform and enrich that data as it's being moved through your pipeline and into the curated data set. So that does bring us to curated data. So this is a layer of the data that contains your high-value information that's served to the consumers of your BI applications or your analytic solutions. So this could be data analysts, this could be data scientists, or essentially anybody who's accessing your formatted data, essentially data modeled the same way you would think about data in a data warehouse. So this is structured and modeled and cleansed and enriched in the format that you would need to be able to serve through your analytics application. This data in this zone is usually highly governed as well as highly documented and secured. And it might be stored in a format such as Delta, which is essentially optimized Parquet that's enhanced with a transaction log to enable advanced capabilities like merge operations, time travel, and significantly better performance when you're talking about using that type of file for analytical queries. All right, so as stated in the previous slide, a couple slides back actually, Synapse Analytics is the ideal hub for any type of modern analytics solution in Azure. And here's some of the reasons why. So Synapse provides a rich surface area with T-SQL for data analytics. It supports a lot of additional languages and tools depending on exactly what you need to do to consume that data, as well as integrated enterprise-grade security. The two SQL pools that are available within Synapse, the dedicated and the serverless pool, include everything from our modern data warehouse across our MPP relational engine. So that engine would have all of the enhanced capabilities for performance and scale, such as indexing, caching, your workload management to scale the service, and so on. Your serverless SQL pool would be more for querying external data. So you would not be materializing data inside that pool because it is serverless and on demand, but it does allow you to query external data, to model raw files, and create virtual tables and views for that logical data warehouse, as I mentioned before. And because it does support T-SQL, it allows for very easy data transformation. All right, so I want to go a step deeper now into the dedicated SQL pool that I mentioned a few times now. And this one I like to make sure I take a minute or two and talk about, because with all the new advanced capabilities of Azure Synapse, it's easy to forget that at its core, it still contains the same distributed SQL data warehouse engine that offers best-in-class price per performance for large-scale, low-latency DW operations. It offers the same industry-leading security that's offered in all the tiers of Azure SQL. Intelligent workload management enables pools and even individual query plans to be scaled in or out to ensure that each user gets the appropriate resources required for all of their use cases. And it supports a variety of data types, tools, interfaces to drive maximum benefit to all users. So looking at this, again, one level deeper here, I do have, it's a little bit hard to see on this diagram, but I wanted to include a diagram just to make sure that everyone understands that when we're talking about the dedicated SQL pool here, this is a pretty heavy footprint from an infrastructure standpoint. This is completely transparent for the most part from the user because it is a managed service. But behind the scenes, the dedicated SQL pool is actually, as I said, an MPP architecture that is built upon 60 nodes of SQL Server that allows data to be distributed across the nodes to optimize performance, data access, and security, and all those things through an advanced storage system that includes things like column store indexes, table partitions, distributed tables, as I just mentioned, data isolation, materialized views, which allows you to essentially materialize result sets optimizing query performance, non-clustered indexes, the result set caching, again, for performance reasons. From a T-SQL querying standpoint, it supports all the things that you would need for an analytics solution. So windowing aggregates, there's an approximate execution feature that allows you to return certain types of query results without actually executing the entire query. There's JSON data support, as we mentioned earlier, that's required when you're talking about these types of big data sets. And from directly within the engine, you can actually score machine learning models in Onyx format. So you can actually invoke the model and use the predict function directly inside of it. And from an object model standpoint, I'll show this as part of the demo, but even though it includes all of those features and behind the scenes, it does have such a sprawl from an infrastructure standpoint. To the end user, the model still looks the same as any other SQL object. So we're still working with tables, we're still working with views, stored procedures, and functions. All right, so moving on to the other flavor of SQL, we do have, as I mentioned, serverless SQL pools. So serverless SQL pools enable quick data exploration. So you can easily use open row set commands to connect to any external data source. It supports various file formats such as CSV, which would be data delimited by any delimiter, JSON, Parquet, any kind of common data format. It does have direct connectors for Azure storage for your entire BI ecosystem. It facilitates the creation of logical data warehouse, as I mentioned, and I'll show how that works. But the idea is, in addition to be able to querying external data, you can also create views over top of that data that can be encapsulated and used to create virtual data models that create a logical data warehouse. So again, downstream, the end consumers don't even have to know that what they're connecting to is not actually materialized on a server somewhere. And finally, easy data transformation, which is a key thing when you're talking about moving data from one stage of this big data environment through to the next, being able to leverage T-SQL capabilities to transform things between file formats or just to apply different functions to transform and enrich the data provides a huge benefit to the user. All right, and the last thing I wanted to touch on that I called out earlier is we also have Spark pools integrated with Synapse directly. So having Spark integrated directly inside of Synapse allows users to pick the appropriate query engine for every scenario without ever needing to leave the Synapse workspace environment. Because the available Hive metastore is automatically synced with SQL Serverless Engine, data can be directly integrated across the platform. So you can query your Hive tables from SQL Serverless. And because it's embedded directly inside of Synapse, that means that you get all the associated benefits, such as security with AAD integration, administration, monitoring, etc. And some supported use cases that are made easier through the use of this embedded engine include, as you can see here on the slide, batch processing, interactive SQL through Spark SQL or SQL Serverless, real-time processing, machine learning, deep learning, graph processing, and so on. All right, so I know I just covered a lot of topics there. We did a lot of talking and covering those slides. So what I wanted to do next was actually jump into a Synapse environment that I have deployed and actually go through and do some hands-on exploration to show how some of these different scenarios can be supported and implemented inside of Synapse Analytics. All right, so before we dive in and start looking at code, what I wanted to do was take a step back and just kind of orient everybody to the architecture of the solution I'm going to be discussing today. So this is ultimately what I'm going to use to demonstrate a lot of the concepts that I just talked about. And if we look starting from left to right, again, the idea within the context of all of these sessions is that we're trying to replicate what a modern analytics solution might look like, and specifically focus on, for this session, the ways that we can take data that's been ingested, model and serve that data for downstream applications. So in this case, the sources of data are going to be on the left here. At the bottom left, you'll see we're going to be ingesting data from our wide world importers transactional SQL database. I'm not going to go through the mechanics of the actual ingestion piece here because we will be talking about pipelines in a later session. And then similarly at the top left here, we have a web orders application. So what I'm going to do is simulate data coming in from a web application that is ultimately going to serve two purposes. One is we're going to be tracking simulated user clickstream data. So the idea is to capture web traffic activity that's being submitted through an Azure Event Hub, through Stream Analytics, and eventually being surfaced in a way that allows it to be queried in near real time by the end users. And then we're going to use Cosmos DB container to as the backend to store documents with product review information. So the idea is as users are using the system, they're submitting product reviews. Those reviews will be stored back into Cosmos DB. And then we're going to leverage the Azure Synapse link to Cosmos DB capabilities to, again, ultimately merge that data with other data in our data warehouse and other data in our data lake, and then surface that to the end users. So once we have all the data ingested, I'm going to show the different zones of my data lake, where that data is going to be stored. And then we'll talk about the data warehouse and the logical data warehouse design that I'm going to implement to be able to serve that data up to downstream users and applications. So with that in mind, let's jump out into my Synapse workspace here. So for anybody who has not seen it yet or has not attended one of the previous sessions in this series, this is the landing page or the home page for the Synapse Analytic Workspace. As I've mentioned before, this is essentially a single pane of glass that's going to give you one entry point into all of the capabilities that we've been talking about within Synapse Analytics. So the first screen that I want to talk about here, get some of this stuff out of the way, is this is our Data Object Explorer. This will allow you to explore both SQL objects and linked service objects that would allow you to explore things like any data storage accounts, any data lakes that are attached to your environment. So as you'll see here, very quickly, if I expand SQL database, we'll see my dedicated SQL pool. So this, again, if you remember, is my MPP relational data warehouse engine that I'm going to use to house all of my data that I need to be able to serve up in a way that can support very high volume, low latency type query patterns. So think of this as, you know, the type of data that you would need to access via direct query in Power BI or something like that. Then you'll see these next two databases have a slightly different icon. That's because they're SQL serverless databases. So remember, we talked about SQL Serverless provides an endpoint for an on-demand SQL engine within Synapse. This is something that's not provisioned necessarily. These databases are just essentially metadata that's used, that's created on top of a serverless endpoint that's deployed as soon as you deploy a Synapse workspace. All right, so then the next tab is our linked services here. You'll see, we'll talk about in a minute, our Synapse Link to Cosmos DB connection. And then we also have, as I mentioned before, our data lake storage accounts that are attached. So here I'll be primarily focusing for this session on these middle three. So we have MAA raw, MAA enriched, and MAA curated. They're going to represent the raw, enriched, and curated data sets that I'm storing in a data lake as part of this solution. So if I was to start there, the first thing we'll see is this is kind of my home landing page. So if you recall what we talked about in our recommended structure for data lakes, the raw zone would be used to store the as-is data sets without any transformations applied. So as we're ingesting data, we would store it in raw format so that we can go back and query that data in its native state at any point if we ever need to. You'll see two folders here. So in this specific solution, as we go through this demonstration today, I'm going to be talking about data in terms of our wide world importers DW. So inside this folder, you'll see data for all of my dimension tables, as well as my sales fact table. Again, just to reiterate, typically you would have something like Azure Data Factory or some type of automated ingestion engine in place here to pull this data in. For this case, we're going to assume that that's already been done for us, as that's going to be covered as part of a later session. All right, the other folder that existed here was my Modern Analytics Academy folder. This folder is being used to capture the raw data off of my Event Hub. So if you recall, I said one of the input data sets for this solution would be clickstream data that's being captured and sent to an Azure Event Hub. And then that Azure Event Hub is using Stream Analytics to pass that data forward. So for the raw data that's being captured off the hub, we're storing it through a partition folder structure in this raw zone of my data lake. All right, so that very quickly just gives you an idea of how we can actually use the object explorers inside Synapse to look at the file structures. So now we've looked at the raw zone at least. The next thing I wanted to show is that we also have the ability using SQL serverless endpoints, as I mentioned before, to actually connect to and query this data automatically. So if I was to go over and look at some of, on my development tab here, look at some of my saved SQL scripts, we could look at the create raw views tab here. And what you'll see is this is actually a dynamic SQL script I have. So I don't know if I mentioned this or not, but again, the serverless endpoint does have, it does support the T-SQL convention. So the same type of queries that you can run against a dedicated endpoint or a traditional on-prem SQL server, you can also submit to the serverless engine. So here I'm using dynamic SQL to create a view for each one of my dimension tables, or in this case, my fact table, where I'm using this open row set function to actually query the file as a delimited text file, and then compile that view on the database server. So by executing this against all my tables, what you'll see is over in my serverless database here, I have a series of views. One for, let's go down to our raw schema here, one for each one of my dimension and fact tables. And using, again, this the serverless engine, I can just, and this environment, I can just right click on one of these views, say select top 100 rows. And now what's going on here is it's automatically generating a query. This is a query that I saved when I created the view. And because the definition of the view has already been established using the open row set command in SQL Serverless, I can actually run this query. And even though it looks like I'm querying a SQL table, behind the scenes, this is going to go scan my files in the raw zone of my data lake, and it's going to return a result set that makes it look like a columnar table. So obviously very powerful here in that this automatically starts to enable things like ad hoc querying and interactive exploration type of exercises. This also can easily lead to simple transformations and manipulation, where then you can save data into the next zone of the data lake. All right, so we talked about the streaming data landing in the raw zone of our lake. We talked about the batch data landing. So finally, the last source data set that I mentioned in the overview was our review data. So the reviews, as I mentioned, is being stored in a Cosmos DB account. And again, I believe this was covered in our last session, but Cosmos would be our a document data store that's managed and hosted in Azure. And here's an example of what the reviews look like when they're being stored in this database. And then if we go over to Synapse, by using Synapse Link, transparently behind the scenes, those JSON documents are pivoted and flattened out and stored in a managed data lake for me. And what that allows me to do is go back to my linked services here. Instead of going into my data lake, I'm going to expand my Cosmos DB section. And you'll see here I have my reviews container. So that's the actual flattened out review data. And again, using my serverless SQL pool here, I can right click and it will automatically generate a select statement using, again, that open row set function. This time, instead of querying a CSV file, it's querying Cosmos DB. And if I was to just execute the query, you'll see that it will bring back the flattened out, pivoted results from that container. All right, so there's my results. These are the same documents that, again, are being stored in Cosmos DB, but behind the scenes, they're also being materialized in this managed data lake for me. Now, what's nice about that is because I'm able to query it from my serverless endpoint, I can also create a view over top of this query definition. So now if I go back to my SQL scripts again, let's look at my Create Reviews tab here. So you'll see I have that same select statement, only now I'm going to persist this as a view. So now within that raw schema, I'm creating views from Synapse Link as well as from my data lake. So what that allows me to do, if you start thinking about it, is now I can start to query that data together. So think about that from an enrichment standpoint, how powerful that could be, taking data from a data lake, a connected link service, or multiple sources, merging that all together and creating a single view over top of that, a single query definition over top of that allows you to query it as if it were a single object. And actually, if we go back and look at, I have another query here just to give you an example to think about the application of that, where here from my enrich zone, using those same types of queries, using open row set, I have my stock item dimension, and now I'm going to do a join to my review data. And by doing that, I can now persist this as a single query where I can pull back a review rating. So now I can start to do things, if you think about it, like I can start to do analysis over aggregates or summary data or merge data of completely disparate data sources, all being joined together through the backend engine that's taking data off of my lake and merging those results together and serving them back to me. So again, really powerful capabilities there through the SQL Serverless engine, and we'll show more about how we can use that to model and serve our data in a second. So now let's go back to our lake here. Now that we've talked about the three sources, we looked at the raw zone in our lake. Let me go into my enriched zone. So now in my enriched zone, what we may want to do here, as we've talked about a few times now, is start to manipulate some of this data, whether that's through cleansing, whether that's through some kind of transformation, or whether that's through applying some kind of AI algorithms or something like that. We can start to run code or execute pipelines to transform that data and then push it through and save it into the enriched zone in our lake. So again, you'll see here in my enriched zone, I have my wide world importers folder. Underneath of that, I have a folder per table again, very, very similar to the raw zone because I haven't done much manipulation to this data set specifically. You will see that I have a different file type here. So as I mentioned in the slides, I've now changed to Parquet because for these type of analytical queries, it's going to perform much better because it's compressed, it has the schema included. So again, because the engine knows how to interpret Parquet files, I can right click and I can say generate a new SQL script. I can select, top 100 from that file. And very quickly now, you'll see that came back much faster. I can start to look at the columnar result sets of those queries. So now that we've talked about the SQL Serverless endpoint a little bit, I wanted to jump into the Spark engine a little bit to start talking about some of the capabilities that are enabled by having access to the Jupyter notebooks and the Spark clusters directly inside of Synapse. So the first script I want to look at here is just a very simple notebook that I'm using to read and write data sets. So just an example of how you can go out, you can read Parquet or read CSV or read whatever files you need to from your lake, apply whatever transformations you need to apply over basically data at any scale as long as you have access to it, and then start to write it out in different formats. So this is something that could be automated to move data through and enrich data between your raw and enriched zone or your enriched and curated zone, basically at any point in the process to enrich that data as necessary. Another thing you can do then is use these notebooks to persist the definition of a data frame as a table. So if you recall, when I go back into the workspace here, if we were to look at the types of databases available, we explored SQL databases. There's also this concept of a lake database, which is it's a collection of Hive metadata essentially over top of the data in my lake. So here I've actually created a Spark table called reviews to house that same data set of my review data coming off of Cosmos DB. And I did, even though it's already in my managed lake for my that's accessible through Synapse Link, I did want to persist it as a table to demonstrate another very powerful capability. And that is from this table, I can now right click and you'll see that I have another menu option available to me, and that's machine learning. So by doing, let's say, for instance, I have this review data now, and I want to take the actual verbatim reviews that are being submitted by customers, and I want to apply sentiment analysis to those reviews, and then persist the sentiment score that comes back from my algorithm. I could easily write all that code and I could execute it inside the notebook, but I could also just right click and have the code generated for me. So through this menu, if I say predict with model, you'll see I get a wizard that pops up that allows me to do anomaly detection or sentiment analysis. And then I can do next, next, next. And ultimately what it will do is open a notebook and generate this type of code for me. So here you'll see this is system generated queries. It's essentially defining my model. It's applying the model to create a data frame and then displaying the results. So if you think about this in terms of how do we move data from one zone in the lake to the next and enrich that data along the way, this would be a great example of how I could include this in my notebook and ultimately materialize those results and persist that to my curated data set so that when my downstream users and applications are querying the review data, they'd be able to easily have that, to easily retrieve that score and that sentiment analysis based on the execution of this model. All right, so inside of the Synapse workspace, I've been bouncing around a little bit here, but hopefully it's starting to become clear all the capabilities that are available, everything that we talked about today. So everything from landing data in its raw format in your raw zone, moving it through the different stages. Along the way, you can then start to transform and enrich and shape that data so that you can model it for downstream users. So finally, what I want to do is talk about how you can then access that data outside of this environment. So to start, let's look at our curated zone here. You'll see here the format's a little bit different. I still have my WWIDW folder. Underneath of that, I now have my tables essentially split by what would traditionally be like a schema definition inside of a regular relational database. So I have my dimension tables here, and then I have my fact table split out separate. Under each one of these tables, you'll see I have a log file along with my Parquet data, and that's because this is now using Delta format. I mentioned before, Delta is essentially an additional layer on top of Parquet that makes it even more efficient for these type of analytical queries. It allows you to do time travel. It allows you to do CRUD operations. It allows you to do a lot of additional things in addition to just reading the data back. So that's the format that I chose for my curated data set. And again, because of the interoperability of all these different engines inside of Synapse, I can just right click on my folder, say new SQL script and select, tell it I have Delta files, and it will automatically scan the entire directory underneath, generate this code for me. It understands its Delta format. It understands it just needs to find the log file, and it returns the results. All right, and again, just as before, because I'm able to execute the SQL query to return those results, I'm able to select this data using any tool that could connect to and execute SQL protocols. So just to show you what that might look like, if I hop over into Management Studio here, to start, if we start with our most basic, simplest way of modeling and serving the data, that would be most in line with what many of you are probably most familiar with. What I'm expanding here first on the left-hand side is my dedicated SQL pool. So remember, my dedicated SQL pool is my provisioned SQL data warehouse. This is the distributed SQL cluster that you have the ability to scale and pull some levers to control just how much concurrency can be supported, just how many, what type of resources are actually deployed and available to your queries, and scale out and scale in and all those types of things so that you can make queries perform as efficiently as possible. So you'll see here, after importing and transforming all of my my Y-World importers, transactional data, I've got it modeled here in essentially a regular star schema with my dimension and fact tables. The one difference that I want to highlight here is because we are using that distributed system and we do have all those levers and knobs to turn for performance and security and efficiency and all those things we talked about, in the table definition, this is the fact table. You will see here in the middle that I am specifying a condition for distribution. So I'm saying that because I'm going to have millions and millions and millions of rows in my fact table, I want to distribute that based on my primary key. That would be a common practice for any large fact table. Whereas here in a dimension table, you'll see that's not the case. And I'm actually just using a replicated distribution strategy so that this data is actually going to be cloned across every node in the cluster so that it's going to make any queries where we need to join to the dimension tables much more performant because it eliminates the need to move data, which is in these big data scenarios often the most costly operation that impacts performance. So that covers kind of the star schema part of this. Now there is one other table here. So if you recall from the very beginning, the idea is that when we were streaming in the clickstream data to monitor user activity on our website, I said I wanted to be able to query that data in near real time. I use that term purposely because in my mind, near real time is a little bit different than event stream processing. And that's because stream processing would typically be for something like telemetry data or real-time log information that you were looking for trends or anomalies or something like that. In this case, I just think of this as more something where you want to be able to see a value as of a specific point in time. So I want to see up to the second what's happening, but I don't necessarily need to see that on like a dashboard that's trending real time. So because of that, I'm just going to stream this directly into my dedicated SQL pool. And because of the types of patterns it can support and the resources available, if I were to just look at like here, so this is my clicks table where I'm streaming the data. You'll see right now I have 687, 895. I believe this stream is still running. Whoops. There we go. So you'll see the number is changing as each new record is written to the database. We're immediately seeing those results. And notice there's no lag in the, other than the breaking connection, there's no lag in the query actually serving those counts back to me. So again, another example of a reason you might look to use a dedicated SQL pool. So that would be for scale, for performance, to support these types of low latency query patterns and so on, especially where you need to be able to query the database directly. Now, in cases where you don't need to be able to support those direct query use cases, and you are going to have kind of not as high of a bar for requirements around latency in the result set, or you're able to apply caching on top of it for something like a Power BI import model or something like that, that's where the SQL serverless engine and endpoint might become a really attractive option for modeling your data. Let me collapse this and expand the server above it. Now what we're looking at is this, you'll see this has a dash on demand. So this is connecting to the same Synapse workspace, but now I'm looking at the serverless SQL endpoint. Again, this is the one that comes out of the box. It's not provisioned, but this is where I've been storing the definition of all my queries along the way as we've gone through this demonstration today. So you'll see here, coming from my curated zone, I also have views that define my dimension and my fact tables. along with views from all of my other zones of my data lake, and I can use those to query the same data. So if I wanted to select from this dimension.city table here, this is actually going to run against that view that, if you recall, is nothing more than a Parquet file in my data lake that this SQL endpoint and this view, as I've defined it, understands how to go read, leveraging the open row set function. So as you see, that performs just fine. I get the results back that I need. So this is another way that Synapse allows you to kind of model and serve that data for downstream users without having to worry about provisioning that dedicated SQL footprint out in Azure. All right, so I think that's everything that I wanted to get through from a model and serve standpoint as we look at this solution today, as I've kind of designed this in my environment. Again, just really quickly to recap, from a data storage and acquisition standpoint, a lot of these topics have been covered in a previous session. From a data pipeline standpoint, some of these topics will be covered in a future session, but what we focused on today is the different options for storing analytical data inside of Azure Synapse specifically, and also how we can model that data, whether it's in a data lake, a data warehouse, or a logical data warehouse, to meet all of your requirements when it comes to a modern analytics solution. And with that, I'm going to go ahead and wrap up this session. Just a reminder for everybody, we do have resources available out at aka.ms/MAA, where you'll see the landing page for this Modern Analytics Academy. Out there, you'll be able to see an overview of all of the sessions that are being offered, along with recordings, resources, links to documentation, and potentially, depending on the session, some hands-on material that might be out there to allow you to get some practice using some of these services yourself. So with that, I'll say stay tuned for future sessions to come, and I thank you all for your time today.